Close.
All right,
Going.
rolling.
All right, are there any specific ones from that electrolysis sheet from yesterday you want me to go over?
Yeah,
6.
Number what?
Let's go with 6.
Wait, what?
I'm cool with 6 too. We can go over 6.
I mean, we can go with
Which one?
multiple.
I mean, 6 and 9. That's the one I wanted to have.
Okay, 6 and 9. All
Those are
right.
the two that were confused.
Okay, so you've got aqueous magnesium sulfide. And I can't emphasize this enough, you have to realize what you have in this solution. You have water, you have magnesium ions, and you have sulfide ions. That's it. So the only possible thing you could have as a reactant is one of those three. Magnesium ions, sulfide ions, water. You cannot have elemental magnesium, you cannot have elemental sulfur, you can't have hydrogen, you can't have oxygen, okay? These are the only possible things you can have as reactants. Not sulfur, not oxygen, not hydrogen, nothing. This is it, okay? That's it, nothing else, okay? So you're gonna dump in electrodes, you can hook it up to a cell. These are non-spontaneous reactions. So look at the potential things that could go through a reduction process, okay? So could you take the magnesium and make it gain 2 electrons and turn it into elemental magnesium?
It could happen.
It could happen, okay, legitimately, it could happen, okay? Now, you're probably gonna not take sulfur 2 minus and make it gain an electron and turn it into S3 minus, okay? Probably not gonna happen, okay? So let's eliminate that, okay? And then you have the reduction of water, okay? And again, you have to understand the reduction of water versus the oxidation of water. So this is what we talked about yesterday. So on the reduction of water, that's 2 H2O yielding, or plus 2 electrons, yielding H2 plus 2 OH. Okay? Now, where's magnesium on the reduction chart relative to water? Above or below it?
Below it.
Below it. So what's nature going to choose?
Water.
Nature is going to choose the reduction of water because that's going to be more likely to happen than the reduction of magnesium. So there's the reduction part, okay? So now you have the oxidation part. So on the oxidation part, right, can you even find sulfur on this chart?
No.
No, so guess what?
Water.
It's going to choose water. So water is both reduced and oxidized. So basically you just end up with 2 H2O yielding 2 H2 plus O2. That's it. So on number 6, that's the other one where water is both reduced and oxidized.
I figured out number 9. So
You did?
Can you do number 8 then?
Yeah. Okay. So, because this is going to form the basis of some calculations that we're going to do today. So you have to visualize what's happening. This isn't aqueous lithium fluoride, okay? This is molten. So anytime you see molten, there is no water, okay? Water is not an option on anything that's molten because the only thing you're doing is you are melting the salt itself, okay? So where you have like 8 and 3, don't let water be in there. It's not. We're not dissolving this thing in water. We're melting the salt. So you have to visualize what's happening. So within this, because it's the molten salt, you have lithium ions and you have, what's the other one? Fluoride ions, okay? All right? So that's what you're going to start with. This is what you have available to you. So if you look at this, so what's the lithium going to do? Is it going to gain an electron or lose another one?
Green.
It's going to gain because you're going to end up with elemental lithium. Is that going to happen at the cathode or the anode?
cathode.
Cathode.
Red cat, yeah.
Red cat, right? So at the cathode, okay? You're gonna be making elemental lithium. Just like yesterday when we did the electrodes and the silver began to form on that one, okay, that's what you would see. You would begin to see lithium forming on that cathode. Now, you're gonna take the fluoride and you're gonna make it do what?
Oxidize.
Yeah, it's gonna turn into F2 and then 2 electrons, so we gotta balance that, right? Okay? So out of this, so here's, you're gonna multiply this by 2 because it's lithium and you gotta have 2 electrons, right? And then you're just gonna add them together. So you're just gonna start with, there's a couple of ways you see this written. Sometimes you see it written as LiF turning into lithium and 2 fluorides, or F2, okay, like this. Sometimes you'll see it written as lithium plus 2 fluorides yielding 2 Li plus F2. Either one is fine. So you can either start with 2 lithium fluorides and separate it into lithium and the fluoride, or you can start with the ions and then turn it into elemental. No matter what, that's what you're going to end up with. But you have to realize on the molten ones, you are starting with the ionic form. Okay? Hello.
So last physical therapy equipment.
Sure, that's what they always say. Okay. So make sure on all of these that you are balanced with charge and you are balanced with number of particles. Okay? Make sure that you balance both of those. Okay? So for example, like on number 5, there better be a 6 somewhere as a coefficient.
Yeah, water is a productive
And number 7 better involve a bunch of 2's. Like on 7, a 2 should be somewhere in everything on number 7, either a subscript or a coefficient.
Right.
Whoa.
Okay? Literally, on number 7,
Yeah, no, there's literally 2's in every single one.
everything should involve a 2, either as a subscript or a coefficient. Okay?
Is that not oxide?
Anything else,
Oxide just oxygen, 2 minus.
but it's O2
O2
minus. Yeah.
Oh, so I missed that.
Wait, where is that on the chart? What?
Could we go over number 7?
Wait.
Yeah. So on number 7, 7's the one exception to the over-under rule. So on number 7, your chloride ions are what, even though chloride is actually above water, that's why I said that's the one exception. So your chloride ions are actually the ones that are going to turn into elemental chlorine and 2 electrons. So this is the one exception to the over-under rule. So chloride on number 7 is what's going to be oxidized, and then the water is going to be reduced.
Can we go over 3? I just realized I did hydroxide instead of oxide, and now I don't know what I'm doing.
Okay, what's the formula for aluminum oxide? Or what's the charge on the aluminum?
AL203.
So the charge on aluminum is AO3 plus,
Yeah.
and oxygen is going to be what?
O2.
O2 minus. So what are you going to get out of this deal? You're going to get elemental aluminum and
Oxygen gas.
oxygen gas. Then just balance it.
That's it?
Yeah,
Oh.
but you have to balance it,
I mean, yeah, I can do that.
okay?
I can't do that.
This is such a train wreck.
Look, do the half reactions. Do the half reaction for aluminum, do the half reaction for the oxide. And then find your common number of electrons.
I thought
Yeah.
that the water would be reduced because it has like.
On number
There's
3?
no water.
There is no water, it's molten aluminum oxide.
Oh.
Is oxygen water cheap?
There is no water, dear.
Okay, yeah, I realize that now.
Yeah. There is no water.
Is there a 6 in number 3?
Huh?
Is there a 6 in number
Is there a 6?
3? Yeah.
Yes.
Okay, we're good. We're cooking. We're cooking aluminum oxide. Aluminium oxide.
Remember talking about sodium chloride yesterday, about melting it, and then
Yeah?
I saw a video last night, it just showed up in my recommendation feed about someone taking raw sodium and dunking it in, melting it and then dunking it in chlorine gas and making sodium.
Oh, yeah, it's very, very, very expensive.
Wow, YouTube is wild.
It's true, Google's listening to this conversation.
It is scary, like, I have had like conversations with people,
And it just shows up as an ad.
yeah, on Facebook. It's like, and this is stuff like, I remember it was a device, I don't even know what it was, I'd never even heard of this thing. Like, I would have never searched for it in a million years. That ad started to show up.
Yeah.
It's like, that's just creepy. Okay, anything else? Going once, going twice? So,
Which half reaction for oxide do we use on number 2?
it's just O2, you have O2 minus, right? And you're just gonna turn it into elemental oxygen, there's no, it's just the oxidation of oxygen. It's just O2 minus turning into oxygen.
Right.
That's it. Just like, it's just the reduction of aluminum turning into Al3 plus. There's nothing else, you can't have anything else. It's just O2 turning into O2, or O2 minus turning into O2. That's it.
She's kind of
I don't know. RE13? Huh.
That's not the real.
Yeah, just do one half reactions for that.
So, yeah. I mean, something like it's,
Putting in two there. I don't know what I'm doing.
Oxygen is a gas, always has to be O2.
Yes, you're right.
Lots of gas.
You're so right, Jason. You're so right.
I've never heard those words in my life.